All right, lesson 7.3, the sine and cosine functions. So we're going to start with a circle. Now notice what I did. I changed on your notes, these have ordered pairs, and this is equal to 1. So notice that I changed that. So pretend like those ordered pairs aren't there and change that 1 to a radius, okay? Secondly, throughout the video, you'll see at 3 different times a page number with problems to complete. So after I do the slide, pause the video and attempt the problems in the textbook before moving on. They will be checked next class. Okay, so we're talking about trigonometric functions and they're based off of circles. So we're going to call P any point on a circle, okay? We know coordinates are x, comma, y. So if I think about going from the center of the circle, to get to the any point on the circle, I move x units to the right and y units up. There are my coordinates. Okay, so if I go from the center to a point on the circle, that's my radius. So throughout this entire lesson, we maintain the fact that in the equation of a circle, x squared plus y squared equals r squared. So if I'm given a point on the circle, I can find the radius of the circle. If I'm given an x coordinate and a radius, I can find the y coordinate. So we'll continue to come back to this equation of the circle. Okay, let's focus on this triangle that's formed. It's a right triangle. So if I go back to good old geometry and my SOHCAHTOA, then if theta is my rotation from my initial ray, the cosine of theta would be the adjacent side, which is x, over the radius, which is r. The sine of my angle measure, opposite of theta, is my y value over my radius. And the tangent of theta is equal to opposite, which is y, over adjacent, which is x. So these first few problems, you're going to be given a point on a circle, and you're going to be asked to write the sine, cosine, and tangent. So take those coordinates, plug it into the equation of the circle, and then according to the x and y coordinates, determine what your, I think it just asks for sine and cosine. Okay, so now, again, this doesn't necessarily have to be the these ordered pairs at the end, but when you have a radius equal to 1, that's called our unit circle. Okay, so your unit circle is centered at 0, 0, and it's with a radius of 1. Okay, the quadrants themselves tell us which trig functions are positive. So when we're dealing with functions on the unit circle, your x coordinate gives you the value of the cosine of your angle measure. The y coordinate gives you the value of the sine of your angle measure. Okay, so in the first quadrant, since x and y are both positive, then my cosine function is positive, my sine function is positive, and my tangent function would also be positive. So this A represents that all trig functions are positive in the first quadrant. In the second quadrant, x coordinate is negative, y coordinate is positive. So the S stands for the fact that only the sine function is positive in the second quadrant. In the third quadrant, both my x and y coordinates are negative. So if I divide two negatives, then only my tangent function is positive in the third quadrant. And lastly, in the fourth quadrant, my x coordinate is positive, my y coordinate is negative. So only my cosine function is positive in the fourth quadrant. We will continue to come back to this fact, right? Angle measures and that their quadrants determine the sine, as in the value being positive or negative, not the sine of my angle measure, which gives me the value of the sine of an angle. Okay. So again, determining the quadrant will determine if the trig function, the particular trig function, is positive, negative, or 0. Okay, so sine of 100 degrees. 100 degrees is in the second quadrant. In the second quadrant, my y coordinate is positive. Therefore, a sine of 100 will be positive. Okay, 90 degrees. 90 degrees is up here on the positive y-axis. I'm on the unit circle because I'm given these ordered pairs. So the sine is my y coordinate. So if the ordered pair is 0, 1, the sine of 90 degrees is 1, and that's a positive value. Sine of 5 pi over 4. So we filled out the angle measures and their corresponding radian measures in lesson 7.1. So when I look at this, 5 pi over 4, that's bigger than 1 pi. So since my top number is my bottom number plus 1, 5 pi over 4 is in the third quadrant. In the third quadrant, only the tangent function is positive. So the sine of 5 pi over 4 has to be less than 0. Okay, tan of negative 30 degrees. So again, back to lesson 7.1, a negative angle measure just represents a clockwise rotation from start. So I always start here. If I rotate negative 30 degrees, okay, that puts me into quadrant 4. So negative 30 degrees is just a fourth quadrant angle measure. In the fourth quadrant, only the cosine is positive. So the tan of negative 30 will be a negative value. 270 degrees is down here on my negative y-axis. The ordered pair is 0, -1. Cosine is the x-coordinate, so my cosine of 270 is equal to 0. Okay, 150 degrees. 150 degrees is a second quadrant angle. In the second quadrant, only my sine function is positive. So cosine will be less than 0. 11 pi over 6. So now I go back to my relationship with radians. My top number is 2 times my bottom number, minus 1. That makes 11 pi over 6 a fourth quadrant angle. In the fourth quadrant, the cosine is positive. So cosine of 11 pi over 6 will be greater than 0. And then lastly, 38 degrees is a fourth quadrant angle. All our trig functions are positive in the first quadrant, so that'll be greater than 0. Okay, so pause the video. Complete problem number 4. Okay, so complete each statement. So again, it's all about comparing quadrants. Sine of 30 degrees is a first quadrant angle. We talked about from start, if I rotate negative 30 degrees, that'll put me in the fourth quadrant. Sine of 30 degrees is positive. Sine of negative 30 degrees is negative. So the positive angle will always be bigger than the negative angle. Okay, cosine 30 is fourth quadrant. Cosine of negative 30, 30 is the first, negative 30 is the fourth. So I'm rotating the same amount from the x-axis. In the fourth quadrant, the cosine is positive, so these values will be equal to each other. All right, lastly, so let's go back to our values. 300 degrees was here, 315 degrees, and then 330 degrees were our angles in the fourth quadrant. Okay, so let's go back to what we know about the unit circle. My coordinates here are 0, -1. My coordinates here are 1, 0. The cosine is the x-coordinate. So look at what the x-coordinate here is doing. My cosine value is 0 at 270 degrees, but it increases to 1 at 360 degrees. So the cosine of 300 has to be smaller than the cosine of 330 because the cosine value increases as I rotate through the fourth quadrant. So cosine of 30 has to be less than cosine of 330. It is not because 300 degrees is less than 330 degrees. Okay? And we can talk about that more in class. So more problems from the text. Pause the video. Complete those. Okay, solve for theta, state all possible solutions. So when I have an exact value of 0, 1, or -1, I know my answers come back to the coordinate axes. Okay, so when you're answering this question, sine of theta equals 1, you're answering where, at what value of theta, so at what angle measure is my y coordinate equal to 1? That's the question you're answering, because sine is associated with the y value. So answer A, my y coordinate is equal to 1, only up there. So in degrees, what's that angle measure? That angle measure is 90 degrees. In radians, that angle measure is pi over 2. But remember, we said angle measures are not unique. So if I start up here at 90 degrees and I perform any rotation, any full rotation around a circle, I'll always end up here. So it would be 90 degrees plus every rotation of 360 degrees. And we represent that rotation using the letter N. So this all possible solutions means I have to take into account every single infinite value for theta. So if we're dealing with radians, one full rotation around the circle is 2 pi radians. And then I got to put my N in there because it means I can rotate an infinite amount of times and always end up at the same point. All right, where's the cosine equal to 0? So now we're answering, where does my x coordinate, at what angle is my x coordinate 0? So now notice here I have 2 answers. You only need to write one answer. And we start with the first one that happens. So this also occurs at 90 degrees and therefore pi over 2 radians. But now notice, to get to my next angle measure, I don't have to rotate a full circle. I only have to go a half of a circle to get to the next value where my x coordinate is 0. So if I only rotate half of a circle, that means I'm only traveling 180 degrees. But I need to account for all the infinite rotations, so I put an N there. And then in radians, what's 180 degrees? That would be pi radians, and I need to put my N in there to represent the infinite amount of solutions. Okay, last one. Where's my sine function equal to -1? So where's my y coordinate equal to -1? It only occurs at one value. Keep doing that. So my angle measure is 270 degrees, or 3 pi over 2 radians. Notice, since it doesn't happen anywhere else, then every full rotation of the circle, so 360 degrees, or 2 pi radians, and I have to account for all solutions, so I need that N in there to tell me it can happen an infinite amount of times. Okay, so I'm going to stop the video there, but make sure you have all of those in-textbook problems completed. There are 2 more examples, but we'll do them in class together. All right, that's it.